Okay, let's continue with our basic rules for inequalities. We're going to continue from where we stopped in our previous class. We treated the rule for rule 3a. Let's look at the rule 3b. If a is less than b and c is greater than 0, then a times c will be less than b times c. If a is less than b and c is greater than 0, then a times c will be less than b times c, and a divided by c will also be less than b divided by c. If that rule is true, then let's say if 3 is less than 7 and 4 is greater than 0, then 3 times 4 will always be less than 7 times 4. And that will give us 12 less than 28. Also, 3 divided by 4 will be less than 7 divided by 4 by our standard of fractions. So that rule is true if a is less than b and c is greater than 0, then ac is less than bc, and a divided by c is also less than b divided by c. Basic rule 4, the negative integer rule, or when c is less than 0. Basic rule 4 is also talking about the negative integer, or when c as an integer is less than 0. In that case, the rule tells us that the sign, the operational sign of inequality will change if that happens. So in a, if a is greater than b and c is less than 0, then a times c will be less than b times c, and a divided by c will be less than b divided by c. That is, if 7 is greater than 3 and minus 2 is less than 0, then if we multiply 7 times minus 2, our answer will be less than 3 times minus 2. That will give us minus 14 less than minus 6. You can see that minus 14 is less than minus 6. So the rule is true. Then if you divide 7 by minus 2, it will still be less than when you divide 3 by minus 2 by our operational standard, because we're having minus 7 over 2 less than minus 3 over 2. So that is what the rule states for the a part of the negative integer rule. Then the b part states that if a is less than b and c is less than 0, then a times c will be greater than b times c, and a divided by c will still be greater than b divided by c. Let's use 4 less than 10 and minus 3 less than 0. So if you multiply 4 by, let me use dot as my times. I'm using dot as my times. If you multiply 4 by minus 3, the result you get will be greater than multiplying 10 by minus 3. That will give us minus 12 and minus 30. So minus 12 is greater than minus 30. If you divide the both side, 4 divided by minus 3, the result you get will still be greater than dividing 10 by minus 3. So you'll be having minus 4 over 3 greater than 10 over minus 3. So in the negative integer rule, or when c is greater than 0, the sign of operation changes because c is less than 0. If you're dealing with greater than problem and you're multiplying or dividing by a negative result which is less than 0, your sign will change in the both side when a is less than b or when a is greater than 0. Provided that c is less than 0, the sign of operation will change if you're multiplying the both side by that particular negative integer, or you're dividing both sides by the same particular negative integer. The fifth rule states that if a is greater than b and c is less than d, where d could be any number, then a minus c will be greater than b minus d. Let's see that problem here. The a part of that 4 rule states that if a is greater than b, let's say 10, greater than 4 and 3 is also less than 5. If A is greater than 4 and C is less than D, that is, if A is greater than B and C is less than D, then our A minus C will be greater than B minus D. Let's work greater than C. Here we have our A, here we have our B, here we have our C, and here we have our D. So we have 10 minus 3 greater than 4 minus 5. So here we have 7 greater than 1 minus 1. So you can see that A minus C will be greater than B minus D if A is greater than B and C is less than D. If you subtract C from A and subtract D from B, the result you get at A minus C will be greater than the result you get at B minus D. And we're proving that here. 10 minus 3 is greater than 4 minus 5, which is 7 greater than minus 1. The B part of it says if A is less than B and C is greater than D, then A minus C will be less than B minus D. Use 4 less than 5 and 3 greater than 1. You notice that if you take out, the rule states that A minus C will also be less than B minus D. That will be 4 minus 3 will be less than 5 minus 1. This will give us 1 less than 4. So you can see that that rule is true if A is less than B and C is greater than D, then A minus C is less than B minus D, and we have it done here. 4 less than 5 and 3 greater than 1. So 4 take away 3, which is B, will be less than 5 take away D, which is 1. So we have 1 less than 4. So the rule of the fifth rule is correct, the fourth rule is correct, and the continuation of the third rule, which is B, is also true. So we'll have the problem here solved to help us prove those rules that are stated. So in our next class, we'll be dealing with the last set of basic rules for inequalities before we can now start dealing with the calculative part of inequality. So see you in our next other class.